Okay, let's continue in what is convolutional neural network. Why they call it convolutional neural network? Okay, convolutional neural network is a neural network with a convolutional operation instead of metric multiplication in at least one of the layer. So that is the definition of convolutional neural networks. Meaning that we can say that if there's a one network which at least have one convolutional operation, doesn't matter which layer that we formulate the convolution operation, so you can consider then one as a convolutional neural network. Okay, but you see later you will see that most of the well-established CNN use a lot of convolutional operation instead of metric multiplication. So again, I think you a little bit don't understand what is the meaning of metric multiplication. Okay, we will try to get back into this discussion later. What is the difference between convolutional operations and metric multiplication? So in convolutional neural network, it seems to be the convolutional operation is replacing the metric multiplication um, in implementing the neural network itself. Okay, again, this is the one that we have discovered before. Okay, of course, this is how the networks looks like. So again, because this one, the hidden layer is more than one, so we can consider it as a deep learning. So this we can consider as a deep neural network. This one. Okay, this is deep neural network. Okay, deep neural network. So okay, this is example of CNN architecture. As you can see that the architecture of CNN is a little bit different from deep neural network. Okay, for deep neural network, which is extended from the ANN that you learned before, the pictures is look like this, meaning that they always have a pictures represent, the circle is represent neurons, and then the arrow there represent the connection between neuron, and so on. But when you learn deep learning, especially CNN, the picture represent CNN is a little bit different. They use something which is in square shape there. Okay, so why when you learn a CNN, the architectures of CNN if is draw in square base picture, as compared to why not just draw like the one that you learn in ANN before. So the problem is because in CNN, normally CNN is very popular in representing the two-dimensional network, as compared to this one. This one is just a one-dimensional network. So that's why when in this course, when I want introduce to you with CNN, I implement later. We will see that how to implement CNN in image, because CNN itself originally is a two-dimensional neural network. It's not one-dimensional neural network. So two-dimensional neural network, of course the input must, the data should be in two-dimensional signal. So the one that has two-dimensional signal is image, because image, the signal is in two-dimensional signal. So that's why it's more suitable to use CNN for image, or is more compatible to use CNN for image as compared to other application. Because if you dealing with one-dimensional signal like speech or ECG or EEG, then you need to do some major modification to your CNN, which is not covered in this syllabus and not is covered in these courses. Okay, so why they change the pictures there? Why they change the picture representation, the architecture representation picture, instead of using a circle to represent neuron, and then now they change into square to represent the CNN architecture. Okay, if you this is because of the reason is because of that. One is because of CNN is a two-dimensional neural network. Another one is that if you are still using this kind of circle representation, then your network become more and more complicated to be seen, and because it's not meaningful for you to interpret something in the architecture. But that does not mean you cannot draw CNN in this form, but of course it's a little bit difficult for you to interpret in terms of to interpret the architecture and so on. Okay, 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 again, this is the ANN that we have learned before. So why I call it one-dimensional neural network is because each and every layer here you have, the size is in one-dimensional. For example, this one is, if you make it in metric form, okay, it's something like this. Okay, this point represent this point, this point represent this point, and this point represent this point. So it's the size is is 3 times 1, so it's a 3 times 1 matrix. For this one is 4 times 1 matrix, and this one is 1 times 1. So everything is with size of 1. So that's why I call it as a one-dimensional 1D neural network. Okay, but for CNN, let's say I want to draw my CNN in this way, then because the input is image, so that means the matrix is not 3 times 1. It should be, for example, let's say my input image is 3 times 3, because image is always in the pixels. So assume that you have an image of 3 times 3. Okay, the image of 3 times 3 can be represented in 3 times 3 matrix. Okay, because every matrix element inside this one, the value here is represent the pixel value or the intensity value of that image. Okay, if I want to draw the CNN in this form, okay, in this form, so then I need to draw something like this. Okay, you have one neuron this here, you have another neuron here, and then you have another neuron here, and then this is just represent this row. And then how about this row? Then you need to draw something like that. Okay, and then you have to draw something like that. So then this is the input, means that every pixel here as an input. Okay, this is still as, okay, this whole circle here represent the input layer only. Okay, it's not other layer, it's still at the input layer, because this one will be accepting one value of the intensity value of this one. This one will go into this one, this value will go into this one. So as you can see, if we want to draw CNN in the previous ANN architecture, which is in this form, it's very hard for you. This is just represent your input layer. So how about, let's say I will have another hidden layer. So normally the hidden layer will have let's say the hidden layer have 10 times 3 at 10 times 3 times 3. Okay, you can have a three-dimensional hidden layer. Okay, then you need to have, you have here, you have 10, and then you have 3 there, and then this for example, this is just one surface, then you need to multiply with 3. It's the three-dimensional. This is just 10 times 3, but you will have another 3 here, meaning that you must have a 3 layer, something like this. You must have more layer like that in three channel like that. You have a 3. So this is 1, this is 2, and this is 3. So imagine that if you want to draw your CNN in this way, so it's a little bit difficult for you to, you know, to connect your arrow there, because you don't know which part of neuron at the input going into which part of the neuron at the hidden layer. Is very difficult for you to draw. So that's why it's not practical to draw the CNN in this way, because now the CNN is already in two-dimensional. It's not just two-dimensional, the input is two-dimensional, but the hidden layer can be go up into 3D. So that's why it's very difficult for you to see and interpret if you are drawing your CNN in this way. So that's why they are changing the picture in representing the architecture. Instead of using the circle, it changes it into that square, because that is more easy to see what is actually happened. Okay, that is the reason. Okay, so that's why when you talk about CNN, don't get confused. It's still a neural network, but they change the way to represent the architectures. Okay, meaning that instead of you are using a circle to represent a symbol of neuron, now the neuron itself is not drawing, is not appear in these pictures. It's not because they just assume the input and the output of that layer. Okay, meaning that this is the input, and the hidden layer is here, the one that you don't draw. Okay, this is the one you have a lot of neuron, a three-dimensional neuron, because it's very complicated to see. Like I said before, if you want to draw the neuron, then it will become something like this. Okay, then instead of drawing the neuron, it's in the new architecture, it does not drawing the neuron. Okay, the architecture don't show the neuron, but it only show the output of that neuron. Okay, so that's why if you can see in these pictures, okay, actually the neurons of the first hidden layer is here. When the inputs going into this layer, the output is this one. So this is the output of this hidden layer. Okay, and then again for example, this one. Okay, just escape this subsampling. The subsampling don't have any still don't have any some neuron there. Okay, normally it happen at the convolution. So at the convolution side, actually there's a hidden layer here. Okay, when this input going into that hidden layer, the output is this one. Okay, so that's what now that is how we can say that that's the easiest way to represent our CNN architecture. Instead of drawing the network, or instead of drawing the neuron represent the architecture, we are using the input and output of the hidden each neuron to represent the architectures. It's more easy, but later we'll discuss what is the meaning of convolution, subsampling, and fully connected layer. So as you can see that like we discussed in the definitions there, convolutional neural network, most of the time you can realize that there's most of the process is convolution instead of matrix multiplication. The matrix multiplication is also known as a fully connected in CNN. Okay, now we discuss about what is matrix multiplication. Actually, during when you learn the A and N, okay, when you want to find, let's say, okay, let's say, okay, again, you know that this one will have your W, the bold W, 2, and then this is your input X. So in order for you to find your net over here, so net, okay, you will have here net. So the net 3, the net 2 is equal to, of course we assume there's no bias, so then it will become, if you write in metric form, you will transpose your W, your W 2 and multiply with your X there, okay, to get the net 2. So this is what we call as metric multiplication, or of course we call, previously we call it as a dot product. So this is what we call a matrix multiplication. Okay, so by definition, when you increase the more and more hidden layer, and this neural network will become deep neural network. So deep neural network is actually will implement matrix multiplication in each and every hidden layer that you have in your network. In your network, in the network that you have designed. So if you have a number of hidden layer is 3, then you have each and every hidden layer must do matrix multiplication in order to find net 2, net 3, net 4, and so on. So that is a matrix multiplication, meaning that each and every neuron here, in other word, what is meaning by matrix multiplication is that to find each and every net in each neuron over here, you must multiply with W. Each and every W here must connected together with the previous layer. Okay, that is happen. Okay, meaning that okay, that's why another name for matrix multiplication, if you talk about the architecture that represent matrix multiplication, is that it is fully connected. So that's why in deep learning they call that, if you the connection between the previous layer and the current layer, if the connection is all the neuron is connected together like this, it's called as a fully connected layer. Okay, this layer is called as a fully connected layer because the arrow come from the previous layer is connected between that the neuron in that layer and the neuron at the previous layer is connected each and every there. What I mean is that each neuron in the current layer is connected with each and every neuron in the previous layer. So that's why you can see this one is connected with this one also is connected with this one is also connected with this one. So I forget to draw the arrows there. So if that is happen, okay, that is also called as a fully connected layer. And if the fully connected layer happen, then to compute the net 2 over here, you need to do a matrix multiplication. So that is what happened in deep neural network when you have a lot of hidden layer. So meaning that the operation that dominate that architecture is matrix multiplication, meaning that let's say you have this is your input layer, then this is your hidden layer number 1, this is your hidden layer number 2, this is your hidden layer number 3, and so on, before you have a output layer. So if you when this is happen, of course this is called a deep neural network. And deep neural network, actually each and every neuron here, you need to do the matrix multiplication in order for you to find each and every net over here. You have a net 1 here, and then this one is net 2, this one is a net 3. So each and every net here, you need, when you want to obtain the value, you need to do matrix multiplication. So yes, we realize that this is still deep neural network, and deep neural network is under category of deep learning. But because of you have a lot of matrix multiplication, and it kind of redundant, it will make your even you have a good high speed computer nowadays, but it's very difficult for the current computer technology to compute the deep neural network. Is because each and every layer you must entertain that matrix multiplication, which is very heavy to be compute. So that's why an alternative way to represent a deep neural network, which is a little bit simple, they're replacing the deep neural network with what we call as a CNN. Instead of using matrix multiplication, they are replacing the matrix multiplication process or fully connected layer here with what we call as convolutional operation. Okay, convolutional operation. So that's why CNN is called convolutional neural network, because most of the matrix multiplication operation have been replaced with convolutional operation, because convolutional operation a little bit simple as compared to matrix multiplication, because you will reduce the number of W to be used in each and every layer. So how actually we can reduce the number of W, or the number of parameter called W in each and every hidden layer? Later we'll discuss that. Okay, so that is the some idea why we call why we learn CNN, and then before that why I introduced to you with deep neural network, because deep neural network is a standard from your artificial neural network that you learned before. But still deep neural network have some problem when each and every layer need to implement matrix multiplication to get net 1, net 2, net 3 and so on during the pass forward operation, which is very heavy for computer to compute. So that's why instead of using matrix multiplication, they replace the convolutional operation in each and every matrix multiplication operation. But of course it's not all layer in that network have been replaced with convolutional operation. You will see later, actually is a combination between convolutional operation and fully connected. Normally fully convolutional will happen from the first phase up until the second last. Okay, the last operation it will go into fully connected, means that it's a matrix multiplication back. Okay, like in this picture that I show you before. Yep, this one. As you can see that here we already replace it. Instead of using matrix multiplication, you are replacing the operation with convolution. And then here you also replacing the matrix multiplication with convolution. But the last process before you get the output, it use the what we call as fully connected. fully connected is actually the other name lah, because I already mentioned to you, if you are seeing the word fully connected, is actually is a matrix multiplication, or matrix multiplication, or in other word, this operation, the fully connected operation, is similar to the previous artificial neural network operation. So why they call it fully connected is because that I have already mentioned to you, is that because in this picture, because the arrow there is a fully connected between this one, this neuron, and this neuron is fully connected. This one and this one is fully connected. This one is also fully connected with the previous each and every neuron inside the previous layers. Okay, so that's why they call it fully connected. Okay, so what is the difference between fully connected and convolution? Okay, this is just again what happened when you apply a CNN. It's similar to what we discussed during the introduction, meaning that you feed the neural network with your raw data of, in this case is the raw data is image, then you don't have to worry about how to design the feature, because the computer will decide itself how to find the best pattern for the computer to outperform in classifying the or labeling the image. Okay, so in other words, this is this animation show you how actually the neural network works. Now you can see that we don't draw the neuron in a circle shape anymore, because it's in 2D. So because it's in 2D, then it's very hard for you to draw. So this picture is in other words, roughly show you how actually the process happen when you apply the image, because the image is in two-dimensional signal. Okay, but it's still not correct. This animation is still not so correct in representing the CNN there, but roughly the process is like that. It's similar to what we learned before. Just the difference is that the operation now is not every layer. When you want to do a pass forward, you need to apply the matrix multiplication, because now the convolutional operation is dominant in each and every process before you can pass forward into each and every layers going towards the output. So